Okay, our lesson today is over the number e. Now, e is approximately this number right here, which is actually an irrational number. It occurs in nature and eventually got to the point where mathematicians got really lazy and they got tired of writing this number all the time, and so they decided they would call it e, kind of like pi. And e is called the natural base because it occurs in nature. Now, it is a base and the rules for exponents are the same. So, we're going to evaluate in your calculator the following values. So take a second, go through and do it. Depreciate, your rate becomes a negative. Instead of it being a positive decimal, it'll be a negative decimal. Okay, so for number one, we would type it in as 4. Then we would find our e to the x button. And then in our parentheses, we would type in our negative 2. And at that point, when you type that in, you should end up with approximately 0.54. If you didn't get that, go back through, check your entry, make sure you did it correctly. Number 2 should have had your 0.5, then our e to the x with the 3.6 in parentheses. And once you typed it in, you should have approximately 18.299, which you could almost round to 0.3 if you wanted to. All right. Next up, we have exponential growth and decay. This is your basic formula for exponential growth and decay. Now, n sub 0, the value right here, is always going to be the initial amount that you get. So whatever you start with, whether we're talking money, whether we're talking candy, whether we're talking ponies, it's always going to be the initial amount. K is your constant. In other words, it's always going to be a percent. And if you think in equations, we can't put a percent straight in, so we have to go through and we have to divide it by 100. And then thirdly, t is going to be your time. And generally, when we measure time, we always measure it in terms of years. So at this point, we're going to go into a couple examples. All right, take a minute, read the problem. Okay, they give you the equation right here, which is very important. They also tell you that the number of years since 1950, which means anytime we're talking about 1950, our time is going to be 0 for that time. Now, it's asking, has Bakersfield experienced growth or decline in population? So go through, let's plug in a number here and see if we get a number bigger or smaller. And when you do, you should end up with it being a growth. Because if you look at this rate right here, that rate is positive. Positive means it's going to be a growth. Population in 1950. Let's go through, plug 0 in for your time, and see what you get. When you plug it in, 0 times the 0.397 is 0. Anything to the 0 power becomes 1, so we're left with 33,430 as our population in 1950. Now the third question, which just projects the population in 2010. So essentially we do the same process, except our time, you got to think, 2010 is 60 years later than 1950. So where our t is up here, we need to plug our 60 in its place. And when you do, you should end up with approximately 319,000. Okay, next equation. It's pretty much the same equation we had, it's just in different terms. Balance, which is the same thing as your after amount. So if you need to, think of it as your after. P is the same thing as your n sub 0, or your before, or your starting amount, whichever way you like to think about it. I know my writing's kind of bad, I'm using my mouse. T is still going to be your time in years. R is still going to be your interest rate. Remember, we take the percent and we divide it by 100. So let's go through and let's look at an example or two. All right. Oh my goodness, you can already see all that. Let me erase some of that. Makes it kind of hard to see. Okay. So, as you can see, here's our equation that we have to use. And it gives us all this information up here. So, if you read the problem, it does not tell us the after amount, but it does tell us the starting amount of 12,000, which went right here. E has to stay. Your rate, it tells us the percent, and if you think we got to move the decimal place 2 times, so 1, 2 gives us a 0 right here. So that's where the 0.09 came from, and our time is 5 years. So if we go through and type that into our handy dandy calculator, we end up with the 18,819.75. All right. And if you look at the next one here, take a second, read the problem. Okay, here's your equation we're going to use. We do not know our after amount because it doesn't say, because it says we have to find the balance after that time. We did deposit 6,500, so that's where that amount came from. We have our E. We have our 4.75%, which remember, we got to move the decimal place 2 times. So 1, 2 gives us 0.0475. And it does tell us our time of 10 years. And when we plug all that in, we end up with 10,452. To recap, here are 3 formulas. These two are essentially the same thing. This one you talked about last year when we were doing math 2. We are not talking about that one this year. With interest, your rate is a positive when we're talking growth. Your rate's going to be a negative when we're talking decay.